Welcome to the DIY Honda Garage channel. DTC P0703 indicates a malfunction of the brake pedal position switch, which plays a crucial role in the vehicle's braking system. This switch detects the position of the brake pedal and sends the necessary signals to the Engine Control Module, ECM, or Powertrain Control Module, PCM. When the switch fails, it can lead to driver safety concerns, as the vehicle may not recognize a braking action effectively. The malfunction might be triggered if the brake pedal is pressed lightly for an extended duration while also pressing the accelerator pedal, causing DTC P0703 to store. It is vital to diagnose this code thoroughly, as the brake system is integral to vehicle safety and performance. In this presentation, we will outline the components affected, possible causes, symptoms, and a step-by-step troubleshooting procedure. The brake pedal position switch, NC, is an essential component in the Honda Pilot's brake system. It is located beneath the dashboard, where it is activated by the brake pedal's movement. This switch communicates with the PCM, sending crucial information about whether the brake is engaged or disengaged. If the switch malfunctions, it can disrupt the operation of various systems, including cruise control and stability control. The malfunction of this switch is critical because without accurate signals from the brake pedal, the vehicle might not function as intended, potentially compromising safety and control. Regular observations of this switch can help in early identification of issues before they escalate, ensuring better vehicle performance and safety. Several factors can lead to the DTC P0703 being triggered. First, wiring issues may arise, such as short circuits or open wires affecting the signal transmission from the brake pedal position switch to the PCM. Secondly, a faulty brake pedal position switch itself can cause this malfunction, rendering it unable to send accurate signals. Additionally, problems with the connectors, such as corrosion or poor connections, can impede signal flow and trigger DTC P0703 as well. Each of these areas must be diligently checked during troubleshooting to ascertain the root cause and address it effectively. Understanding the role of each component aids in expediting the diagnosis process and ensuring a thorough inspection. When DTC P0703 is present, several symptoms may manifest, indicating that the brake pedal position switch is malfunctioning. One of the most common issues is a cruise control malfunction, as the vehicle may not disengage cruise control when the brake pedal is pressed. Additionally, the driver may experience an inconsistent braking response. The vehicle may not recognize braking at certain times, causing unpredictability during operation. Warning lights on the dashboard may also illuminate, alerting the driver to a potential issue with the braking system. These symptoms are crucial as they can denote a serious safety risk and hence must be promptly addressed to maintain optimal vehicle safety and functionality. Begin troubleshooting with Step 1 of diagnosing DTC P0703 by turning the vehicle to the on mode. Utilize the Honda Diagnostic System, HDS, to check the pertinent parameters without pressing the brake pedal. The focus should be on ensuring that the signal conditions match the established thresholds, specifically observing parameters like cruise brake/idle and stop/SW. It is essential to carefully note the values displayed during this evaluation. If the current conditions align with the thresholds, proceed to Step 7. Conversely, if they do not, further investigation will be required, leading you to Step 2 to inspect the brake pedal position switch installation. In Step 2, you will need to check the installation of the brake pedal position switch. Initially, disconnect the brake pedal position switch and reconnect its 4P connector securely. Following this, while pressing the switch's rod, reevaluate the parameters using the HDS. Again, the key parameters include cruise brake SW idle and stop SW. Your aim is to verify if the current conditions match the specified thresholds. If they match, adjustments may need to be made to both the brake pedal and the switch itself. However, if they do not match, the troubleshooting process leads to Step 3 for further assessment. Step 3 involves more in-depth diagnostic measures to determine the failure area. Begin by turning the vehicle off and disconnect the 4P connector from the brake pedal position switch. Connect a jumper wire between terminals A and B at the connector to facilitate testing. After connecting the jumper, turn the vehicle back to the on mode and again measure the parameters using the HDS. This testing helps identify whether the brake pedal position switch or other components may be faulty. If the readings align with the expected thresholds, it indicates the switch requires replacement, while any mismatches prompt further steps, leading you to Step 4. In Step 4, the focus shifts towards checking the IG1 ACG line and identifying any associated issues. Start by ensuring the vehicle is in the off mode before removing the jumper wire previously installed. Restart the vehicle by turning it on and check the voltage between designated test points. These points include the brake pedal position switch connector number 4 and the vehicle's body ground. Confirming the presence of battery voltage in this scenario indicates that the IG1 ACG wire is functioning correctly, allowing you to progress to Step 5. Conversely, if no voltage is detected, prepare to initiate repairs, as there might be an issue that affects the circuit integrity. During Step 5, the goal is to verify the integrity of the cancel SW line. Start by turning off the vehicle completely. Engage the shorting of the SCS line using the HDS for over a minute. This process helps in preparing the system for accurate testing. Following this, disconnect the PCM connector A51P and establish a connection between the relevant terminals in the brake pedal position switch connector using a jumper wire. Then, turn the vehicle on and measure the voltage at the PCM connector number 24 versus the body ground. If there is a sustained battery voltage, it signifies that the cancel SW wire is in proper condition. Thus, further checks or even a known good PCM should be considered. In contrast, any absence of voltage leads to an immediate necessity for repairs on the wiring. Step 6 revolves around checking the vehicle's fuse linked to the brake pedal position switch function. Confirm the vehicle is turned off before inspecting the specified fuse in the under-dash fuse relay box, which is labeled number C7, rated at 15A. If the fuse is intact, it leads to a potential issue with the IG1 ACG wire that must be addressed. On the other hand, if the fuse is blown, it indicates immediate replacement is necessary. If a replacement fuse doesn't solve the problem, inspect for any shorts in the connected circuits, as they could be the root cause affecting the brake pedal position switch's operation. Proper fuse functioning is essential for the reliability of electronic components in the vehicle. At Step 7, you will conduct a subsequent examination of the brake pedal position switch signal. Begin by turning the vehicle to the on mode and ensure that the brake pedal is pressed. Utilizing the HDS, review the parameters for cruise brake SW idle and stop SW, again, to check for alignment between current conditions and expected signals. If the system exhibits the correct responses, it may indicate an intermittent failure that requires attention to connections or terminals that may be malfunctioning. Monitoring prior freeze data can assist in reproducing any failures under similar scenarios. Ensuring the integrity of the connections is paramount in rectifying ongoing issues related to the brake pedal position switch. In the final troubleshooting step, you will concentrate on evaluating the brake pedal position switch itself for functionality. A thorough test of the switch is necessary to confirm its operational status. If the switch is found to be fully functional, The troubleshooting focus should shift to potential shorts to power within the cancel SW wire connecting the PCM to the switch. However, if the switch fails the test, a replacement will be required to restore operation and eliminate DTC P0703. Always ensure that any replacements are done with quality parts to uphold the overall integrity and reliability of the braking system in the Honda Pilot. After completing all necessary repairs and replacements concerning DTC P0703, proper verification is fundamental to ensure the effectiveness of the interventions. Begin by rechecking all system signals related to the brake pedal position switch using the HDS. This verification step guarantees that the previous issues have been resolved post-repair. Following this, it is critical to perform a test drive under varied conditions to confirm that the switch operates correctly and that the brake system functions as intended. Observing the behavior of the vehicle after repairs allows for the identification of any lingering concerns, ensuring comprehensive resolution of issues associated with the DTC P0703. To prevent the occurrence of DTC P0703 in the future, regular preventive maintenance should be adopted as best practice. Schedule regular inspections of the brake pedal position switch to ensure it remains in optimal working condition. Additionally, cleaning of connectors can help prevent corrosion, which often leads to electrical failures and malfunctions. Conducting periodic checks on wiring integrity ensures that no shorts or open circuits can affect the signal transmission from the switch to the PCM. Proactive measures significantly reduce the risk of unnecessary DTCs appearing, thereby enhancing the long-term reliability and safety of the braking system. The comprehensive analysis of DTC P0703 highlights the critical role of the brake pedal position switch in vehicle operation. Understanding its functionality and components helps ensure effective troubleshooting, leading to timely diagnosis and resolution of issues. As a vehicle technician, it is essential to perform thorough checks and the methods outlined to identify any underlying problems. Diligent attention to preventive maintenance can also enhance the longevity of the braking system. Ultimately, addressing DTC P0703 promptly assures the performance and safety of the Honda Pilot, fostering a better driving experience. Please like and subscribe to the channel. See you next time.